Today we're going over lesson 5.3, which is solving trig equations. Verify that the x values are solutions to the given equation. So we got 3 tangent squared of 2x minus 1 equals 0. We got x equals pi 12 as well as 5 pi 12. And we'll show how those work for a solution. We're simply going to plug it in, so 3 tangent squared of 2 times pi 12 minus 1. Okay, so this is going to give us pi 6, 2/12 of pi 6. And now what is tangent of pi 6? And then we're going to square that value, right? So unit circling. Right, we got 1, 0, 3/2, 1/2, and that's as far as we need for this one. However, we will use both of the rest. So just filling it in quick. Do a little out of practice with this. Definitely recommend getting in practice to being able to write that. And again, x, y values, cosine, sine, tangent was going to be the bottom values over the top. So pi 6 would be 1/√3. So I'm going to write 1/√3. Generally, we don't write it this way. However, we don't need to rationalize when we're going to square it. So that is what this value is. And now we're going to square that. So square of 1/√3 gives us 1/3. And now bringing back the times 3 and minus 1 from the rest of the equation. Right? So 3/3 is 1. 1 minus 1 is 0. And so that verified that it worked. The next one is almost the same thing. So we're just going to jump back into what would 5 pi 12 look like if we plugged it in quickly. So tangent squared of 2 times 5 pi 12 minus 1. This is going to give us 5, 6. So looking at our unit circle a little bit larger here, right? 5, 6 would be over here. We would have a negative value for our x's and a positive for our y's. So this would give us negative 1/√3 squared. But then when you square it, the negative is going away, right? Because then we're going to have negative times negative is positive. Square root of 3 times square root of 3 is 3. So we're still left with 3 times 1/3 minus 1, which gives you 0. So that one also worked. Okay. Next one, 2 cosine of x minus 1 equals 0. So again, just plugging it in. All right, clearly we're going to simplify the cosine of pi thirds first. Cosine of pi thirds is half. If you weren't sure, going back, here's my pi third, cosine is the x value, it's half, right? So again, using our unit circle. So make sure you're familiar with how to use it. 2/2 is 1, minus 1 is 0, right? 1 minus 1 is 0, and that confirmed that was right. Next, what about 5 pi thirds? So the only difference, and again, we're basically at this point right away, right? We're just, what is 5 pi thirds? And then we're going to cancel the rest with math. So a reminder, 5 pi thirds, we got 3/3, 4/3, 5/3 is over here. All students take calc, so this one's positive. Cosine is positive there. And it's the same thirds, right? We had thirds, so this is also 1/2. So 2 times half is 1, minus 1 is 0. And we again confirm that 5 pi thirds will be a solution. Next, we're going to find the x-intercepts of the graph using a graphing calculator. So here's the graphing calculator. Again, we are plugging in sine of pi x over 2. Sine, second pi, x button, divided by 2. And we're looking for, specifically it said, all solution between 0 and 2 pi. So, x value, we're just going to leave that. And we're going to move down to the y, x value, we're going to switch that to, let's say -1 to 6.5. Okay. And so I'm graphing it. Each of those marks is 1. So now looking at the picture here, right? We've got answers of 0, 2, 3, 4. So 0, 2, 4, and 6. And then it runs off the graph at 6.5. So our solutions based on the graph are 0, 2, 4, and 6. Now we could have also traced them. So just a reminder, you can do a second trace. We can plug in the value, right? We could say what's the value of x is 0 to see that we got 0. You could also do second trace, and we're looking at the, again, 2 for a 0, but then you're going to have to press enter a couple more times because you're looking for zeros for the left and right boundary, give us 0. And you could do that around each value. So we'll just do one more just to prove it here. We're going to the right a bit here, and press enter wherever, and just press it one more time once we're past that intercept or root 0 solution, whatever we call it. And we get 2 for 1 to the e to the negative 13, which is just a fancy way for 0. Some calculus will give you that. So all even numbers are going to work. Okay. We stop at 6 because 2 pi is approximately 6.28, right? And pi is 3.14, an approximate. But it's hard to bracket at 0, so that's why 0 works. For those who might question, why is 0 in there if 0 is part of it? It says 0 less than or equal to x less than 2 pi. Next, solve this equation for x, list all solutions. Now this adds quite a few answers here. So starting off, how this is going to work is you're going to solve for cosine of x equals a value, right? And we're just going to do your general opposite of PEMDAS, so minus by subtracting from both sides to get 2 cosine of x is minus 1. And now I want just cosine of x, so dividing by 2 on both sides. And now I'm left with, where does cosine of x equal negative half? Now you definitely want to know your unit circle. I'll quick jot it down one more time, and we'll cross-reference using this one. We got, right, writing it down. For 0, pi 6, pi 4, pi thirds, pi half. Now, it did say all solutions. So where does cosine equal negative half? Now, all students take calc. Cosine's positive, quadrant 1 and 4, negative in 2 and 3. So we're negative half somewhere here and here, right? And so those values are where? Right here, it's the pi thirds reference angle in quadrant 2 and quadrant 3. So this is going to give us 2 pi thirds. I like to write down our first couple solutions, and then we'll try to make a pattern out of it if we can. We got 2 pi thirds. That's our quadrant 2 answer. And then we also have 4 pi thirds from quadrant 4. Now, we can't say 6 thirds, right? It's not all the evens, because 6 thirds is right there where cosine is 1. So this case, we're just going to have 2 sets. It's going to be 2 pi thirds, and then cosine repeats every 2 pi. So we're just going to say 2n, where n stands for any integer, right? So positive or negative whole number. And then 4 pi thirds is also going to have its own set, plus 2n pi. So those are all possible solutions for cosine of x equals negative half. Okay. There are times where we'll have a pattern. Well, maybe every, the way we can kind of put a couple of these answers together to get a pattern, like, oh, we're adding 2 thirds, but it doesn't work for the next one of 6 thirds, right? So trying patterns, sometimes it'll work, sometimes it won't. Next, 2 sine squared of 2x equals 1. Okay. Solving just like normal, just recognize that it is a square, so divide by 2 on both sides, and I get sine squared of 2x equals half. Now we can't divide by 2 in the middle there, by the way, so we'll deal with that at the end. Right? So now that's going to be dealt with at the end. But we do need to square root both sides. So I don't want sine squared, I want sine of x. When I square root, we do get plus or minus. So we are solving for a variable. So sine of 2x equals the square root of 1/2 here. Well, multiply by root 2 over root 2 and get root 2 over 2 plus or minus. Now that is in our unit circle. So what we're going to do here is we're going to solve for those values. But we're just going to remember that the values that we find equal 2x. And we will divide our answer by 2 or multiply by half a little bit. So where does sine equal root 2 over 2? Looking back at my chart, right, cosine on top, sine on bottom here, we get root 2 over 2 at pi 4. And again, so I'll draw the circle again. So at pi 4th, we'll get 1. And we'll also get another positive here for all students. We're going to be negative down here, but notice we were plus or minus. So far we got pi 4th, 3 pi 4th, 5 pi 4th, 7 pi 4th, because I'm looking at the pi 4th in each quadrant, right? Reference angles and changing. So writing down those answers quick, I had 1 pi 4th, we had 3 pi 4th. Why not pi half, 2/4? Because that would be right here, right? And that was not a solution. 5 pi 4th, 7 pi 4th. Now, it does help to know your sequences and series. Meaning, can we find a pattern with these answers? Well, the bottom's staying the same. So that keeps it simple. How's the top changing? Well, we added 2 pi. We added 2 pi. Now, what are we really adding? Are we adding 2 pi each time? No, we're adding 2 pi 4th because the denominator is not changing, right? So this was actually plus 2 pi 4th, which simplifies to plus half pi. So our answer is going to be pi 4th plus n pi half. Now, that is for 2x. I just want x. So what this is going to do, if you remember from graphing, 2x may just go twice as fast. So now when I multiply it by half on both sides, this 2 down here is going to distribute to both of the denominators, and we'll get our answers are now going to be pi 8 plus n pi 4. Right? You can always test out the first couple of answers. Because if I plug pi 8 back in here, I get pi 4. I plug 3 pi 8, right, with 1/4 here, then I would get 3 pi 4th once we multiply by 2, which would get us, again, the correct answer. So here's our final answer after we multiply by half to get rid of the 2x. Continuing on. 3 tangent squared of x minus 1. Okay, plus 1 to both sides. 3 tangent squared of x equals 1. Divide by 3 on both sides. And again, why not square root? A, 3 is not a perfect square. B, you got to divide first, right? I like you to think of it as we're working our way up PEMDAS. It doesn't always work this way, but we're going adding, subtract, multiply, divide to get to the parentheses that is tangent of x, right? So we got to do the multiply, divide, and adding before we do the exponent, which would be square root both sides. So now I've got tangent squared of x is 1/3. Square root with the plus or minus. Do not forget your plus or minus. Your answer will be ruined if you forget it. So I get tangent of x. Plus or minus 1 over root 3. Now remembering our unit circle. We've done it a couple times now. This is where our y is 1 half. Our x is root 3. Right? So I'm going to get, where am I going to get 1/3? 1 over root 3. Right? It's going to be here at the pi 6. It's also going to be at pi has a period of, tangent has a period of pi. So this is the pi 6 is our first answer. Our first negative is going to be over here at 5 pi 6. And that's also going to repeat then at 7 pi 6 over here and 11 pi 6. Now, this one doesn't have a nice 90-degree pattern, right? If we have 4, we hope to see that we're about 90 degrees away. It is not. So what's going to happen is we're going to have 2 separate patterns. So our answers here are, we've got pi 6, 5 pi 6, 7 pi 6, 11 pi 6. I'm just showing you why we don't have the pattern. We have a bunch of 6, which is great. Usually, if we have the same denominator, patterns can be there. But in this case, we added 4. The next one we added 2. The next one we added 4. And if we add 2 again, we'll get to 13 pi 6, which would be our repeat of pi 6, which is fine. It would still work. However, we're not looking for the repeat. So what happens here is 1 to 7 is plus 6. 6 conveniently is 1 pi. And from 5 pi 6 to 11 is also plus 6. 6, because it's a period of pi. So how our answer is going to be, it's going to be pi 6 plus n pi. Right? Why don't we write 6, 6? Because it's not simplified. The 6's would cancel. And then we have our first one for our negative was 5 pi 6 plus n pi. And those are the answers there. Now, as you work with these, you'll realize finding these answers are a little trickier than most solve for x's, because you do need to know a lot of your rules. You need to know your unit circle. You need to know, right, when we square root, we're going to add the plus or minus, right? A lot of the basic solve information comes with, but then when we get our answer, it's translating it into a pattern. And that is, again, an extra step on top of an already fairly difficult process. Okay. We have one more. Cotangent of x cosine squared equals cotangent of x. Now, a lot of people are going to see this, and they're going to want to divide by cotangent of x on each side. You can't do it. Do not do it. Can't divide by cotangent of x. Why not? Well, cotangent of x could be 0. Can you divide by 0 to solve? No. And 2, if you treated this like the x, we got xy squared equals x. If you divide by x, you lose potential solutions for x, right? That's kind of how I see this. You can't do it that way. So what you're going to do is you're going to bring the cotangent over through subtraction. Because we can solve for things equal to 0 a lot easier than we can solve for items equal to, say, cotangent. And now, what do they have in common? Ooh, now we have cotangent. Now we can divide, right? Well, we're going to factor. We get cotangent of x, with cosine squared of x left over. Cotangent divided by cotangent is 1. And now I have 2 different pieces. I've got cotangent of x and cosine squared of x minus 1. So we set each piece equal to 0. So cotangent of x equals 0, and cosine squared of x minus 1 equals 0. Well, cotangent of x equals 0, remember, this is cosine over sine. So it's really where does cosine equal 0? And then we've got over here cosine squared of x. We're going to plus 1 to both sides, so it equals 1. Cosine of x equals plus or minus 1 when we square root both sides. So we're looking for our solution for cosine of 0 and plus or minus 1. Looking at our answers here, cosine is 0 at these 2 spots. Cosine is plus or minus 1. We'll color code here. It starts at 1 and then at pi. So our answers on the left side here are pi half, 3 pi half, and that'll continue. And then on the right is 0 pi half and 2 pi half. Doesn't look like that, so 0 and pi. So when you put it in order, we've got 0, pi half, pi, 3 pi half. Now, some people will see that and not see the pattern. So what you got to look, it looks like we're doing a 90-degree motion here. So if we give them all the same denominators, so this will be 2 half, and this technically could be 0 half. We've got 0, 1, half, 2 half, 3 half, and that's going to continue. So this is weird. Do you start with 0 and say we're adding pi n half or n pi half? Right? Well, this 0 is really not doing anything. We're just going to cross out the 0, and we're going to say our answers are x is n pi half. And that'll wrap up this first half of lesson 5.3. Feel free to ask any questions if you have.